Good morning, afternoon, or evening, mathematicians. This is Miss Backfish, and I am here to work a systems of equations problem with you, or to solve a system of equations. And this is a particular type of problem that I've been asked to do by some of my students, where we're talking about interest in two different bank accounts, and that's how the problem is given to us. It's an applications problem. Okay, so here's how the information is presented. It says you invested $26,000 in two accounts, paying 5% and 7% annual interest respectively. That just basically, respectively is to say that 5% is one of them and 7% is the other one. So if the total interest earned for the year was $1,560 or $1,560, how much was invested at each rate? Okay. So how much was invested at each rate? The very last part, that's where my eyes are drawn in pretty much any word problem, because that tells me what is it I'm trying to find. So there's two different accounts here. I want to know how much was put in each account. So those are my two variables. I'm going to have two variables. So let me just call them sort of account 1 and account 2. I need to know how much I put in each one of these accounts. All right. And what I'm going to have to do if I want to have two variables, and let's call them, I'm going to say that my variable for account 1, I'm going to say, let's call that A. You could call it X if you wanted to, or Y, or M, N, whatever, but I'm going to use A and B here. So I'm going to assign variable A to be the amount of money in account 1, and the variable B to be the amount of money in account 2. Define two equations. I need to create two equations. So that's basically, I need to take two facts that are true about two things that I know about these two accounts or how much is in them, and turn them into mathematical equations. All right, one thing I know, the very first thing I know, and this is one of the other big things we always look for, especially in systems of equations word problems, is I know a grand total. So I know that altogether this is how much money I invested. So the amount of money, if I call A the amount of money for account 1 and B the amount of money for account 2, then I know that the grand total of those two comes to $26,000. So I'm going to write an equation out of that. And I'm going to call that A plus B equals $26,000. So A plus B equals 20. So that's my first equation. I need another one. If you want to solve for two variables, you have to have two equations. If you were trying to solve for three variables, you'd have to have three. You have to have at least as many equations as you do variables or unknowns. All right, the next thing we know is something about the total interest, how much interest was earned. And it says for the year, the whole thing here is implying to me that I just want to know about what happens in the course of 1 year. So we're stopping after that year and looking at how much has been earned. So the total interest is $1,560. So I need to write an equation that talks about the interest. Okay? Now the total interest is $1,560. That's not a percentage. That's the amount. That's the actual money that came out of the interest from both accounts. So let's look at how much money comes out of the interest for this account 1. If this is the amount of money that's in there, and this is the one that's paying 5%, we're just going to let the first one be the 5% one and the second one be the 7% one, then the amount of interest I'll get out of that account is 5% of A. And the way we write that mathematically is 0.05 times A. That's the amount of interest that I earn from my first account. And then the account that earns 7% interest and has this amount of money, B, I'll get 0.07 times B out of that account. And again, I kind of know a grand total for this column. I know that altogether, that's going to give me $1,560. So this is the amount of interest money I earn in account 1, or we could just call it account A. This is the amount of interest money I earn from account 2 or B. And this is my total amount of interest, so there's another equation going down like this. So I can say 0.05A plus 0.07b equals 1,560. This is now a system of equations. A system of equations, the same solution set. The same values will solve both equations. So now we get into the solving it. Now it's just like if it weren't an application problem. If you're looking at application problems of systems of equations, then chances are you have recently studied how to solve systems of equations and done things like the substitution method, or another method which is sometimes called, it has several different names. It could be called the addition method or the elimination method or linear combinations. So all three of those are the same thing: addition method, elimination method, and linear combination method. So those are really the two most popular methods to use, algebraically speaking, are substitution or the one with three names that we're going to call the addition method. On this one, really either one of them would be equally, good in terms of sometimes you have a system that's set up so that substitution seems very easy, and sometimes you have a system set up to where addition seems very easy. This one's sort of in the middle. You could go either way with it. I'm going to do it both ways for you. So let's start out and do this by substitution. All right, so the substitution method starts with taking either equation, doesn't matter which one, and getting one variable alone in that equation, isolating one variable in that equation. Okay, so if you're going to do that, generally you look for the easiest thing to get alone. And either one of these fits the bill. You want to get the easiest variable to get alone will always be one that doesn't have a coefficient other than 1. This is 1a, this is 1b. I wouldn't want to try to get this one alone because then I'd have to divide by 0.05. You could do it, but it's just a little bit more messy. So trying to get alone a variable that has nothing but a 1 in front of it is generally the easiest. So I'm going to take that first equation and I'm going to solve for either a or b. I'm just going to go ahead and do b in this case. It doesn't matter which one. All that matters is that now you have a variable alone on one side. Now, the purpose of doing that is so that we can see what a is in terms of b. In other words, I can now think of it, instead of thinking of it as a, I can think of it as this. This means the same thing as a, 26,000 minus b. So that means what I'm going to do is I'm going to go to the other equation, and in place of a, I'm going to put this, because that's the same as a. So you go back to the other equation, and I'm going to go ahead and just write it here. Be careful that you don't think of this as a 6. That's a b. Sorry about that. It looks a little bit 6-like. And if all of this is equal to a, then I'm going to put it right there in place of a. And this is 0.05 times a, so it's 0.05 times all of that. So be careful that you use parentheses because you have to multiply times all of 26,000 minus b. And then I still have the 0.07b equals 1560. What we have achieved here, and this is the main original goal or the first method of solving systems of equations, is we have now gotten it to where we have an equation about our situation that only involves one variable, just the b's. So now I can solve, because if you have one variable, you can solve your equation. So first I'm going to do 0.05 times 2600. Let me grab my calculator here, make sure I don't make any arithmetic mistakes. And I get 1300 for that. This is distributing, so we're doing this times this times that. The 0.05 times both members of this binomial. So I get 1300 minus 0.05b plus 0.07b equals 1560. So next I'm going to combine my like terms here. Negative 0.05 plus 0.07. One easy way to think about dealing with decimals is to think of money. This is like 5 cents, 7 cents. This is subtraction, so it's like I have 7 cents and I'm taking away 5. That's going to be positive 2 cents. Now I am ready to collect my constants, my plain numbers on one side, and I have 0.02, this is B, not 6, equals 260. I should have picked a different variable. And finally, and I will get, I'll show you so that you can see how I type it in and what I get. 1300. Excuse me, 13,000. So B has $13,000 in it. The last thing we have to do with every method of solving a system is once we get one variable alone, we have half the answer basically. We need to go back and figure out what the other variable is. You can take this back now and plug it in to find A in any equation that has both an A and a B. I could plug it in here, I could plug it in here, here. I'm going to plug it in here. It's probably the easiest. So 26,000 minus 13,000. And in this case, and it's just a coincidence, so don't think it's always going to work out this way. In this case, the accounts just split right down the middle, 13,000 in one and 13,000 in the other. So that is my answer. I need to have 13,000 in one account and 13,000 in the other. All right, let's do this same solution by the elimination method. I tend to think of it as elimination, and you'll see why in just a second. But the addition method basically works this way. I'm going to rewrite this, and what I'm going for in rewriting this is I'm rewriting it so that A is directly above A and B is directly above B. All right, so in the addition method or elimination method, what's going to happen is I'm going to add these two equations together top to bottom. But I'm not going to do it right now. I'm going to do it after it's set up in such a way that that's going to help me. What do I mean? Well, the key is this. I need either the coefficients of A, meaning the number in front of each of the A's, or the coefficients of B. I need those to be opposites. So either these two numbers need to be the same number but different signs, that's what I mean by opposites, or these two numbers need to be the same number but different signs. What that will do is when I add top to bottom, they'll give me a 0. Some people call it canceling out, but basically they'll give me a 0. They'll turn into 0, and I won't have that variable anymore. Remember, the goal was to get one equation with one variable so I can solve. So I don't have that right now. I don't have opposites here, and I don't have opposites here, so what do? Well, remember, you can do anything you want to an equation as long as you do it to both sides, so to speak. Anything you want, meaning multiplication, division, etc. So what I'm going to do is remember these currently, let me use a little pencil here. Currently, this is a 1. It's 1A and 1B. If you see an A or you see a B, that's not 0, because if it was 0, you wouldn't see it at all. It's 1A and 1B. So I need to figure out what number to multiply the entire equation by that will give me negative 0.05 here or negative 0.07 here. Not both of them. I only need to get rid of one of them. I'm going to get rid of the B. Why? Because in the last problem it kept looking like a 6. So I'm throwing you out. So to get rid of the B's, this needs to be negative 0.07, which means I've multiplied the entire thing by negative 0.07. So this is also negative 0.07. And now this is 26,000 times negative 0.07. So I'm rewriting the entire equation by multiplying on both sides. Frequent mistake is to forget to do it on the right side, so don't forget to do it on the right side. I've multiplied this entire equation by negative 0.07 on both sides. Let's go ahead and simplify on the right-hand side. Keep setting my calculator down farther and farther afield. We've got 26,000 times negative 0.07. That's going to be negative 1820. All right, so I'm going to go ahead and write that over here. This whole thing becomes negative 1,820. And now you're going to see why it's called the addition method. It's because I'm going to add these top to bottom. So adding these top to bottom, I get negative 0.07 plus 0.05 is negative 0.02 A's. I have no B's because negative 0.07 plus 0.07 is 0 B's. So don't write B. If you write B, that implies you have one. One B is what B is. So don't write any B's. We have eliminated them, which is why it's called the elimination method. And over here on the other side of the equal sign, I am adding negative 1820 plus 1560. That should give me negative 260, I think. But the other day I did a problem like this and I made an arithmetic mistake, so I'm a little paranoid right now. Because it sure does make a mess if you do. So let me just make sure that I'm not making a video with a bad number. Negative 260 is what I get here. And now I have an equation with just A in it, and I can solve that. It might look prettier if I move it a little closer. And then I'm going to divide both sides by 0.02, negative 0.02. And I get A is equal to, should be 13,000, right? If you solve a system of equations, or anything, if you solve it two different ways, you need to get the same thing both times. If you don't, then something went wrong. And that was actually, I mentioned the other day I did something arithmetic mistake. That's how we caught it, is I did the method both ways. I used both methods to solve the same system. And it was like, wait a minute, we're not getting the same answer. All right, that was when I realized I needed to look back and see what I had done wrong. So again, we get A is 13,000. And we can go back and plug in anywhere we want to get the B is 13,000. I would probably do right here, it's simplest. So 13,000 plus B equals 26,000. And we subtract 13,000 from both sides, and yes, voila, B is 13,000 as well. All right, so we did it by substitution, and we solved it by elimination, and now we know how much money was in each account. And it's not always going to turn out to be equal amounts in both. That was just a coincidence. I hope this has helped you and you can do a similar problem now. Thanks for watching.